Aloha, my name is Robert from Ne'epapakahana, and welcome back to the online professional development for the Canoe project. Today we'll be covering Module 3 of 15. So to begin, let's go back to our website, www.stemd2.com. That's www.stemd2.com. After you've logged in, let's go to Students, and let's build a canoe. Now we're going to go down to Unit 2, because Module 3 is in Unit 2 of the Go Math book. Just like in Unit 1, Unit 2 has a short video and a short story that goes along with it. So you can watch the video and the story, or you can just go down to the modules. So let's go down to Module 3. Then we'll end up in this page with a list of activities for Module 3. Module 3 in the Go Math book covers proportional relationships. These are relationships that are linear with a y-intercept of 0. The first activity we'll be discussing is Canoe 3.1.1. So this is the first activity that corresponds with lesson 3.1 in the Go Math book. In this activity, we will be looking at the growth of a single tree in your backyard. So we will assume that this tree grows proportionally with time. So the diameter increases proportionally with age. Here's a table with missing data, and we need the students to fill out the data. After the students have filled out the data in the table, they can use the data to plot a graph. And then they can figure out an equation as well. Once again, we recommend using LaTeX for the equation, but of course it's not necessary. So over here we can type in with LaTeX code y equals, for example, the fraction 1/2 x. So they can copy and paste it here. And when they submit it, you as a teacher will see this instead of this. Of course, they can also write y equals 1/2 x like this. You can do whatever you feel more comfortable with. And once again, over here is the LaTeX guide. Afterwards, the student will use the table, graph, or equation to answer this question. Here's a canoe, and it has a certain thickness, and we want to know how long do we have to wait for a tree to grow in order to be thick enough to carve this canoe out. So we will try to figure out a diameter. We can either use this width, this height, or more better, we can use this diagonal over here. And with this thickness, we can use either the table, graph, or equation to figure out how old of a tree do we need in order to carve this out. Then we need to explain our answer. We need to explain how we determine the thickness and how we use that thickness to figure out the age. Alright, that's it for this activity. Please go ahead and pause the video and take some time to read and reflect on it. Let us know how you might use this activity in your classroom. Alright, welcome back. The next activity we'll be looking at is Canoe 3.2.1. In this activity, we'll be learning about the Heleuma, which is an anchor. So here's a graph showing the lowering of 2 anchors from sea level. And here's a little picture of a canoe with an anchor, just to illustrate what this graph represents. In this activity, we have these 2 anchors and a third one. And we will look at their descent. We will look at their negative rate of change, and we will compare and contrast them. So it's a pretty straightforward activity, but we really like it because it makes use of a negative slope, which we don't see too often in the Go Math book. Okay, that's it. Please go ahead and pause, review, and reflect on this activity, and let us know what you think. Alright, welcome back. Let's go ahead and look at one more activity, Canoe 3.3.2. This is the second activity that corresponds with lesson 3.3 in the Go Math book. In this activity, we will be looking at the growth rates of many koa trees that were planted in your backyard 100 years ago. So over here is a bird's eye view of your backyard. These are the treetops, and the numbers represent the height of the tree. If we assume that the height of the tree changes proportionally over time, then we can figure out the growth rates of trees A, B, and C. We can also use these growth rates to plot the height of the trees over time. And we can also write the equation of these trees. It's important to note that although these trees are all the same age, they have very different growth rates and very different heights. In the last question, we want the students to be a botanist for the day. So we want them to look at this picture and come up with a hypothesis for why the growth rates are so different. Of course, we don't want to focus too much on being right or wrong in this problem. We just want the students to be able to articulate their logic and to share their inspiration with others. What we like most about this activity is that it gives kids who have farming experience a chance to share their knowledge. Alright, that's it for this activity. Please go ahead and pause, review, and reflect on it. Let us know how you can use this activity in your classroom. Alright, that's it for Module 3. See you next time for Module 4.